Hey, this is Mark with Eigen Designs, and if you've been watching my channel for the last few months, you'll notice that I started to produce content in 4K, which has been a real struggle with my old computer. So in today's video, I'm going to be building a Walnut computer case and then putting some of the top-of-the-line computer equipment in that case. There's going to be some computer stuff in this video, but it's more going to focus on some intricate CNC work as well as some traditional woodworking stuff. If that's something that interests you, then stick around and let's get to work in the boardroom. Let me quickly go over the design that I made in SketchUp, because there's a lot of different factors that you have to consider when building a computer case. Not only do you have things like aesthetics and dimensional tolerances that you have to consider, but you also have to think about, how am I going to hide the cables? How is the case airflow going to sufficiently cool the components? So I spent quite a bit of time on the design portion of this, and I've been building computers for over 20 years. And my most recent one was a liquid-cooled computer that looked really cool, but it was kind of high maintenance. And I knew that I wanted to go with something a little bit more simple and have the design element focus on the case rather than the internals of the machine. And because we've got so much to cover, I'm going to skip the milling process and just start out with milled lumber that's ready to be cut on the table saw. To help me with the build process, I had my laptop in the shop ready to go, and I was constantly referencing the SketchUp model to get dimensions and tolerances on various pieces. And I thought it would be simplest to start off with the front panel, the panel that's going to house the glass, which I guess technically is the side panel. But I thought it'd be easiest to start there first and then build everything else around it. Whenever I'm cutting multiple pieces to the same length, I always try to use the stop block on my crosscut sled to make sure that everything is cut to the same length. Once I had the pieces roughly cut to length, I then framed it up on the workbench and then put the tempered glass panel on the side to see how it would fit. I then made some loose markings for where I needed to etch out an indentation in a later step, but we'll get to that in a little bit. To connect all these pieces together, I'll be using Festool's domino, which is a real help in this particular application. I'm using some of the smaller dominoes, and I'll be setting them deeper into the panels because of the indentation step that we're going to take, so that that tempered glass panel sits in that cavity flush. You'll see here that the mortises that I cut are in the lower third of the board because we're going to be taking off about 1/8 of an inch in a later step. Once all the mortises were cut, I installed the dominoes and used a little bit of wood glue and put in the parallel clamps for glue up. To create the inset for the tempered glass panel, I'll be using my CNC along with a 1-inch surfacing bit to essentially cut down 1/8 of an inch so that panel sits flush in this cavity. You certainly don't have to use a CNC to do something like this. You could have cut rabbets on the side panels and then planed each of the cross pieces to the right height before gluing up. I decided to do it like this because I like using my CNC, and I thought this would be helpful to allow me to do other things while this was being cut. Of course, I ended up filming the whole time instead of doing something productive, so I don't think I actually got any efficiency, but I thought it was a creative use of the CNC. So you'll notice here that I took the dust boot off in order to get a good camera shot, and unfortunately shavings and dust went everywhere in the process, so there was a pretty extensive cleanup work that had to be done after that was over. And while I still had the panel and the clamps, I did a quick dry fit with the tempered glass panel just to make sure that it fit. With the side panel done, I then turned my attention towards the base and the top of the computer case. And for this, I used some 8/4 walnut, and I ripped them into 6-inch strips and then glue them together. I'm going to go ahead and skip through the panel glue up because that's pretty routine on this channel. But once I have that 12-inch wide board for the top and the bottom, I used my crosscut sled and my stop block to cut them both to 19.5 inches. I'll be cutting a decorative chamfer around all four sides of both the top and the bottom, so I use my inclinometer to get my saw blade set at exactly 45 degrees. If you've done all four cuts correctly, the corner should come together like this. For the front panel, there's going to be two holes for some fans, but I thought that rather than doing a solid walnut piece, I would do something a little bit more decorative and weave in some maple just to give it a little bit of flair. I got some pieces and stacked them side by side and thought that a nice 1/8 inch strip or maybe 1/4 inch strip of maple would be a good fit for that particular size. So I ripped some thin strips of maple on my table saw and then headed over to my drum sander just to do a few light passes to take out the saw blade marks on both pieces. Overall, I do like how the maple breaks up the walnut and provides a more interesting look. So with everything cut, I head over to my parallel clamps, apply some wood glue, and glue it up as a single panel. I'll be cutting some holes for the fans, but that'll be in a later step. With most of the pieces of the computer case cut, I used some clamps to hold everything together temporarily, just so I could get an understanding of how things were going to look. Now it's time to go back to the front panel and cut the holes for the 140mm fans I'm going to put on the front. The front panel is going to be used in a pull configuration where it will pull air into the computer case, and the upper two fans that will be on the top part of the case are going to be in a push configuration, so it's going to be pushing the air out. So you have a constant flow of cold air coming in and then warm air being exhausted out of the top of the case. Next, I turn my attention to the divider that's going to go in the case. Sometimes this is called a motherboard tray, and they're super helpful for being able to hide wires behind that kind of false backing that you see. So I make some markings on the front and rear panel and then use a 1/2 inch dado stack to cut a channel which that motherboard tray will then sit inside. I specifically wanted the ability to remove the motherboard tray to allow access to other things inside the computer case, so I'm going to have this be a free floating tray as opposed to something that's glued and secured in place. And one of the key features of this motherboard tray is to be able to run wires through it and do all your cable management behind that panel. So to cut the openings, I put a old motherboard that I have lying around onto the plywood backing, and then I just do some rough sketches of where I want those holes to be. I then take those measurements and put them into a Fusion 360 design, and I make some tool paths for a 1/4 inch end mill to carve out those slots. That way the finished product looks a lot more clean and doesn't have any tear out that you sometimes get when using a jigsaw or even a Forstner bit on your panels. Once the CNC had done its thing, I then took a chamfered bit and just added a slight chamfer to all the sharp edges so that any cables coming in contact with it wouldn't be damaged or cut. I then took the motherboard tray over to my paint booth and added 1 coat of black paint just to make sure it didn't catch any attention while it's in the case. In preparation for the glue up, I add mortises to each one of the pieces because I'll be using dominoes not only to provide alignment, but also to provide some strength. And I was really concerned with some of the in-grain glue ups that were going to be involved in this particular project. So I added dominoes to help provide a little bit more structural integrity to the loose mortise and tenon joints. But before we can do the glue up, there's still some CNC work to be done on the rear panel to cut holes for the power supply, the motherboard, and the graphics card. So in preparation of that, I'll be using some M3 brass motherboard standoffs, and I installed these by pre-drilling some holes in some marked locations, and then I used a small socket wrench to actually winch each one of these in place. I started out with a wrench, and then I realized that I could just attach that socket directly to my drill, and it went a whole lot faster. With the motherboard secured in its place in the tray, I can then reinstall the tray and then start to trace out on the back panel where I need to cut openings for the motherboard I/O, for the power supply, and the graphics card. I can then transfer those measurements into a design in Fusion 360 and carve out some holes similar to what we did before with the fan holes. Again, I'm using a 1/4 inch end mill to do all this carving, and as I was designing this in Fusion 360, I was taking careful consideration of where that dado slot is currently cut to make sure there was no overlap between the two. After the CNC made quick work of all that carving, I then take another chamfer bit and just do a quick once-over on each of the corners just to make sure there's no sharp edges left behind that could potentially damage some cables. Now it's finally time to do the glue up, and this was by far the most complicated glue up I've done in my woodworking career. There were about 20 different dominoes that I used. I was using the Typebond 2 dark version for the Walnut to better hide the glue whenever it dries. But there was glue on multiple sides and there was alignment issues, and I tried to put some protective painter's tape down the bottom so I wouldn't have to worry about any glue squeeze out getting onto that chamfered edge that we made earlier. And I think I used just about every single parallel clamp that I have in my collection, but the final product turned out really good. I had really solid squeeze out between each of the seams, and the dominoes really helped on the alignment part of it as well. While this is drying, I had a chance to think about what I wanted to do with the design for the front panel. So this is going to be the front panel that sits in front of the case fan holes that we drilled earlier. And this is going to have a mesh filter behind it to catch any dust before it gets sucked into the computer. And I looked at a couple of different design options, but I quickly landed on this mesh design, which kind of looks a little bit modern, a little bit, futuristic, but still has that contemporary look with some of the woodworking features that I've got on this design. So I put this into my CNC. It took about an hour to carve all this because of all the intricate work. And I did do a once-over with my Festool sander just to make sure that all the fuzzies were taken care of. But I also had to go through and hand sand each one of those holes just to get rid of all the rough edges on the inside. So this part took quite a bit. I then did a quick dry fit and it fell over, but we're going to fix that problem here in a moment. You'll notice in this design I'm using a lot of threaded inserts for pieces that need to be taken on and off and not permanently attached to the case. I use some threaded inserts as well as some machine screws to allow those pieces to be removed seamlessly. Now for the top two case fans, I wanted those recessed to where they sat flush with the bottom of the top panel, if that makes any sense, because I didn't want there to be any interference with the components from the motherboard. So to do that, I carved out a 1-inch deep channel that was wide enough to house both of the fans. And then I turned that piece over and cut 2 holes that were big enough to house the same 140 millimeter fans that we designed for the front part of the panel. This will ensure that the 2 fans can sit seamlessly on the underside of this top panel without interfering with anything from the motherboard. Now this top panel is also going to be held on using threaded inserts, so I used a center punch to locate where those holes needed to be drilled and then install the corresponding threaded inserts. I then repeated this process on the side panel where the tempered glass is going to go. Now, do you remember that panel that was falling down earlier? My solution to this problem was to drill some mating holes and install some magnets that would allow the front panel to be easily attached and removed to clean the filter whenever necessary. I'll be finishing the computer today with a satin lacquer made by Minwax. So I head back over to my paint booth and begin applying it. And one nice thing about lacquer is you can apply coats relatively quickly and not have to sand in between the different coats that you do, which is a big plus for this particular project because all the little holes of this front panel would have taken a long time if I had to sand each individual hole in between coats. With the finish completed, it was then time to install the on button for the computer, and I decided to hide it in the back to not interrupt the smooth aesthetic on the front or the top of the computer. I started off by countersinking a larger bit from the inside of the computer and then finished with the appropriate sized half-inch diameter from the outside. This will allow the on button to sit flush on that surface and then also have the rear nut tightened on the back end. The last thing to do was to add some legs, and I decided to just use some rubber feet because I didn't want the bulky look of some wooden feet. And with that done, the computer case was finished, and it was ready for some hardware. Let's take a deeper look at the hardware that's going to go inside this computer case. First off, we're going to be using NVIDIA's latest flagship product, the 3080 Ti, and we're going to be pairing that with Intel's i9-12900KF, which is their unlocked 24-thread processor built on their 10nm platform. I'm also going to be pairing that with a M.2 solid-state drive and 64 gigs of DDR4 memory. If those numbers don't mean anything to you, that's fine. I can tell you from editing this video on the new computer right now that it is light years ahead of my old computer, and it is exactly what I needed to be able to edit in 4K. Once I had all the hardware unpacked, I began assembling everything, putting it into the case, and things just came together like clockwork. Once all the cables are run, I take all the excess slack in each of the cables and use a combination of sticky pads and zip ties to organize the cables on the backside. I'm probably the only person that'll ever see this, but I think it's part of a good computer build is to have everything organized, neat, and tidy. Once the tempered side glass panel was put on, it was time to turn on the computer for the first time. And I was happy to see that everything functioned correctly. The only thing that wasn't working was some LEDs that I had on the inside of the computer case that was going to help illuminate the inside of the case. I couldn't get those to work for some reason, so I'm going to have to troubleshoot that in the coming weeks. So after proving that the PC can actually turn on, I then took it upstairs into my office and ran it through a couple of stress tests. And really what I was looking for is how does it behave under a high thermal load? Really testing the cooling of the case to make sure that nothing was going to overheat. And I was pleased to see that both the graphics card and the processor stabilized at very healthy temperatures, nothing to be concerned about. So I'm very happy with this overall build. Again, I'd like the LEDs to start working because it's a little bit dark inside the case, but I can fix that in the coming days. What I'd really like to hear about is what you think about this. This is kind of a marrying of two different worlds, the woodworking world and the computer world. I'd really like some feedback on what you guys think of the design. That's it for this one. I hope you liked what you saw, and stay tuned for the next one.